So we'll have 5 talks. The first one is from Coatema. Dr. Thomas Kolbusch is the VP of Marketing and Sales at Coatema. He's based in Germany. And he will be introducing us to the presentation called Upscaling OPV into Production Tech. And I'll give you the stage.
Okay. Yeah, good afternoon, everyone. I will not only speak about OPV, I also speak about third-gen solar cells, which also includes, of course, perovskite solar cells. A long time ago, it also included dye-sensitized solar cells. I will give a short introduction on Coatema coating machinery, situation today in Europe, third-gen solar technologies. I will report on a new European Horizon project, Flex to Energy. Look a little bit into slot die coating for third-generation PV and the equipment being used going into production scale operation. All of the information you find with this QRC code, also my latest presentations, you can download. This makes life a little bit easier. Coatema coating machinery is focused on coating, printing, and laminating equipment. We have our own R&D center in Germany, in Dormagen, and we are focusing on high-tech markets, specifically renewables, printed electronics, and others. And working globally, doing funded projects, and are part of the 88 holding in Hamburg. Our focus areas the last 5 years really have been green hydrogen, fuel cells, batteries, solar. We look into sustainability in products, but also in things how we make products. We look into digital fabrication. I will show a new digital printing method we will implement in November, working on print electronics, and always looking for the next thing in our operation. We have a huge R&D network globally, which are using our equipment. So not only Fraunhofer institutes, we go down to Australia in our operations with our R&D customers. And the last slide, these are the funded projects we're doing at the moment. I mentioned Flex to Energy, but we're working also on solid-state batteries, like in solid, carbon capture systems, like in waterproof. So a mix of technologies we want to understand and we want to implement in our company within the next 10 years. What's the today's situation in Europe? I think it's quite straightforward. We have to go out of the fossil fuels till 2050. Everyone knows this. For this, we need green hydrogen. Green hydrogen, we need electrolyzers. Electrolyzers needs a lot of energy, and this energy has to be renewable. So it's mainly solar, wind, which we use in Europe, either for mobility or for industrial use, like green steel, for example, but also, of course, for heat distribution and replacing gas in our approach. If we look into global solar, the solar generation in 2021 was 1,002 terawatts hours. And most of this, we have to say also, in this market is being produced in China. So 40% of the modules globally are coming from China, 80% in the overall value chain. Products, ingots, wafer cells, and modules are from China. Exports from China reached, in January 2023, $93.5 billion, which is a yearly growth rate of 20%. So the hope, of course, is that the market share of PV in all energy sources will be 20% in 2030, and it looks very good. In Europe, we will reach 1,200 terawatt hours in 2030 and 2,200 terawatt hours in 2050. That's only an estimate, but it's impressive. So what's the share of OPV in this market today? In this 127 billion global PV market, OPV has a very small share of 150 million in 2022. And now the question is, should we spend all our funding in silicon wafer cells in Europe, building up the industry again, which has gone to China already in the 2000s. And I think that's the thing we shouldn't do. We should take all the money, we should invest it in OPV and perovskite to have an independent solar supply in Europe from European producers. And that's an important message because if we want to reach this net zero scenario, PV has to grow aggressively, but the question is which PV we should use. We already see here the solar PV overtaking hydropower, for example, also coming very close to natural gas. And here, of course, the global OPV market is still very small. We only have a few players. Some of the players stopped. Some of the players, like Heliatech, are bringing industrial products into the market. But it's still a very small community. And to grow this community, I think the solution is using money. And it's Flex to Energy, a European Horizon Europe project, which we got beginning of this year, which started, which is using 21 million euros funding in Thessaloniki to build up a production line for OPV with backend, integrated backend. So this is starting. And this is important because we want to push third generation solar. Third generation solar from the history is not only OPV or perovskite. We had dye-sensitized solar cells, printed 6. Just to remember everyone, there's a production chain you have to follow to make modules. And we have to get away from cell efficiency. We have to go into module efficiency and module lifetime because it's an industrial product. What you also see here, the part of the third gen solar in the overall NREL chart is of course not at the efficiency records of silicon wafers, but we also have to see the efficiency of an OPV module over the whole day is different to a silicon wafer cell over the day, and this comparison someone has to do. But we see of course here with perovskite quite impressive numbers already coming into the market, but we always have to see the numbers for bigger scale products which are produced roll to roll. And the most important part, as I mentioned, it's module efficiency, because the modules will be on the roof, the modules will be indoor for energy harvesting. And here we have to see that we're always losing 1 to 2% efficiency from coming to the solar cell to the module. Also here we have to work on. OPV, basically it's thin, lightweight, it's a green mobile power, and that's from the 2000s. We are working on OPV since 2003. It's also sexy. At this time, there was a lot of funding from venture capital in California, in the Silicon Valley on these technologies. But of course, we have several layers which have to be very precisely applied. We have to see the lifetime of the organic chemistry. And we also have to see perovskite as the third wave, at least I have seen in flexible solar applications. Very promising results, but mostly on small scale. So here we have to see the big scale. So these are our core technologies. We're using slot die coating printing processes. We have to use a lot of process inline control to keep the quality on a very high level, high yield. We have drying and annealing processes. And of course, we have encapsulation of barrier films and laser integration. And why we are doing this for such a long time, the reason is something we did in 1999. We got an order for a big lamination line in Los Angeles, where we laminated amorphous silicon solar cells onto roofing membranes. So this was the first idea on building integrated PV. A success story, company did an IPO with $80 million and then disappeared because there was not enough amorphous silicon for all these big roofs in California globally to be covered. But the same pictures you see also in OPV presentations, and some of these pictures I have done at this time just on the roofs we established. If you see the development scheme for OPV, we started with OPV in 2008 with funded projects. And now we have flex to energy as one of our biggest projects in 2023. So it's still an early technology compared to silicon wafers. And there have been a number of different companies in operation which are still there or which already disappeared. And that's the thing we have to see. What we learned, and that's also important to see, we learned a lot of new technologies like inkjet integration, laser integration, high accuracy registration control, inline quality control to operate these systems. And there's obviously this scalability process where you come from a small sample into lab, then you go into pilot, you have to do optimization processes, and now we have to get from pilot, also in perovskite, into production processes, industrialized production processes with a high yield, and the same configurations like in battery fabs, we also have to have in OPV fabs. Finally, one of the visions is perovskite produced on the moon. That's a NASA article, how to produce perovskites on the moon. And funny enough, Blue Origin got a 30 million funding to use moon materials to make solar cells. And that's maybe shortly before my retirement that I see a Coatema machine on the moon. Flex to energy, I mentioned this, over 12 partners from Europe. We have OED as a startup company from Greece, but companies like Mondragon for the back end. And here, within the next 4 years, we will have Europe's biggest production line for OPV, fully integrated, so also with the back end for module assembly. And here we will do millions of square meters per year under industrial standardization, and of course also using Industry 4.0. First pictures of the ideas, it already looks different from the design, and we'll have several meetings this year also on the product. Target here is to have OPV panels with an increased uniformity with 90 watts per square meter, high transparency, and improve lifetime longer than 20 years, because lifetime is the key in solar application on the roof, in the facade, or anywhere else. Main application will be agrivoltaics. That's a new field. I'll show a picture later. Will be integration in automotive and also building integrated systems where we have partner in the project. The millions of square meters you have to bring anywhere. So agrivoltaics using lightweight OPV modules inside of greenhouses is the next trend for us. They're easy to install, and you see here the high potential market we estimated in flex to energy for this approach. And it's not only a vision, I use it in my garden. These modules are in the garden since 1.5 years in German environment. So very hot summers now, but also very wet winter, and they're still fully operational. So you also can do it on small scale. Application systems for third generation PV. And here we also have to go into industrialized systems because we will go to big scale, big working with, high speed. So we look here into slaughter coating for a long time, already in the industry, in the research community. Slaughters have pros and cons. One of the pros is, of course, it's a production system. It's the best to run it 8 hours per day and not to stop. We do slaughters ourselves. We do theoretical simulation of slaughters. And that's the main tool being used at the moment in organic photovoltaics, but also in perovskites. It's always an operation window you have to calculate depending on the rheology, chemistry you're using, but it's a pre-metered system, so you can do very precise simulation with COMSOL on the flow behavior inside of these slot eyes, and also how stable the meniscus will be. But it's not enough because it's an analog system. If you want to change the width, if you want to do specific designs, it's limited. So at Coatema, we're working with Heliosonic. That's a startup company from Altana. And here we're looking to print the unprintable. So here we're looking into higher viscous media. which are basically, and hopefully the video is running. See. Yeah, so it's not running, but basically we're shooting a laser through a donor system, and so the next one will also not work. And shooting the laser through a donor system gives us the opportunity to have bigger particle size compared to inkjet. We can do 100 microns in one step. We can do different heights in the system, in the operation. And of course, it's a digital system, so lot size 1 is possible to reach. And this I see specifically in OPV perovskite as application for the silver grid, where we now have an alternative system to inkjet, which is maybe more robust. Most of the systems we will use in fuel cells and higher viscous systems, but we also will look into printed electronics and OPV. If we look into equipment, a lot of people are still working on sheet-to-sheet systems, small-scale research. We have the evolution now into pilot coaters, which are more advanced, like we're already operating for a long time, also in Greece and Thessaloniki. But this will be the final layout of production lines, because they will have integrated quality control, Industry 4.0, using algorithms to improve the coating performance, and that's the important part in the operation. And in Greece, we will show such a system in a different layout, but similar systems integrated. And here we will demonstrate that we can reach a very efficient yield in the operation. And I'm afraid my last video is also not working. But doesn't matter, you can see it on our website. We have delivered a click and code system just 2 weeks ago to Australia for perovskite application. That's roll-to-roll with integrated encapsulation under nitrogen environment. So that's also possible to do this roll-to-roll. Oh, this one is working. Yeah, it's 300 millimeters. It's still small scale roll-to-roll operation, interchangeable print coating heads, and you have all these processes inline. Yeah, these are the electrical heated dryers we are using, which also can be nitrogen purged if needed. We have integrated infrared heating systems, and here you see how easy and precise we can exchange a slot die coating system. You see here the different numbers of application systems which are available. Basically, the idea here is not to do one layer, dry, roll on again. The idea is to do several layers and then do the encapsulation. And the encapsulation is done under nitrogen environment, so completely enclosed chambers which can be opened. This will already show some more improvement in efficiency on bigger scale. To summarize, I think we need a large-scale aggressive funding for European market players. We should copy China here with 5-year projects on the different technologies, but we shouldn't invest any euro anymore in silicon wafer technologies in Europe. We need reproducible results in every step. Reality check if it's scalable, because if it's scalable, it can be in industrial standard. It has to be a real-life production environment and not rocket science, because you need operator to operate this. We have to bring in, also here from the community, industrial standards, specifically in the back-end area on lifetime, on efficiency. We need long lifetime by low-cost barrier films. That's the problem at the moment. And standardization of device manufacturing, that's the other important point. On all these topics we work. My time is over. We work here together with OED in Greece. So they bring all their process know-how, OPV technology, and an end in. We bring the equipment in, so we can give our customers the whole value chain in operation. So with this, I'm nearly in time, 18 seconds. If you also want to start a career at Coatema, we're always looking for researchers in our research team. You can run 10 pilot lines, do a lot of European projects. It's a very interesting team. And you can download, of course, also our brochures and presentations with this QRC code. Thank you very much for your attention.
Thank you, Thomas. Do you have any questions? Yes. Can you please go close to the mic here?
Hi. Can you hear me? Yeah. I have a question regarding the quality control. So during, you said you want to enable high yields. So how do you make sure to control the printed film when running the roll-to-roll process?
This was part of a few European research projects we did. So inline optical inspection, inline thickness measurement, inline performance control, inline spectroscopy, inline Raman. So we have a whole bunch which also targeting the performance of each layer. So not only seeing optical inspection that there are defects or so, we want really to understand that the performance of the layer is good, because otherwise you're spending a lot of money till you have the final module.
Okay. Yeah. Thanks.
Thank you. Do you have another question? Yes, there's another one. Can you please just go close to the mic?
Hi, Thomas. You probably expected a question from me. In one of the ovens you've shown for perovskites, you would need, in fact, a very clean environment inside. So clean room class maybe 6, if not even more. We had some discussions in the past, and I understood that you mentioned that is not possible from your side. Have you solved that in the meantime, or you are doing it without?
Let's say we are not reaching 6 inside. We work with HEPA filters, laminar flow boxes now, so we can reach, let's say, 10,000.
But it's good for perovskite for that application.
Yeah, you have to see, you also have a roll-to-roll process which produces particles in some areas which you cannot avoid. So the complete clean room inside is quite difficult. It's key, of course, in the coating printing area. So we do measurements, but we will not go into this cleaner environment because then you also have to manufacture all the parts in clean room environment.
But the oven you've shown, it has been proven on that production for perovskite, whether it's
we
pilot
will prove
or
it now. We have several roll-to-roll systems like the one I showed in operation, and then we will get a feedback if it's enough or not.
Okay, thanks.
Thank you. I think we need to a big round of applause again for